So welcome to my presentation today. We had a break for a couple of days or weeks. I had to go to the field for some research works, and then I have come back again a couple of days before. So we are again here to start our course. So today is the last class of this chapter, clouds. Hopefully, we're gonna finish this today, and from next day we'll start a new chapter. So before I start, I should mention that in the last few classes we are discussing about the different types of clouds, and we are also discussing about different types of precipitation also. We have discussed about rain, drizzle, and today we are starting from snow. So in today's class, we are going to discuss about few types of precipitation. That means the classification of the precipitation. And the second part of this chapter, we're going to discuss about the ways how can we measure precipitation. That means different methods of precipitation measurements. So starting from the snow, we have as we discuss about drizzle and rain, that means two liquid formation. So snow is a formation of solid form, that means ice, but not as a ice what we are experienced in our day-to-day life. So snow is a soft and we can say feathery types of ice formation, and depending on the different environmental condition, snow can be formed, particularly in those areas where the melting level, or we can say the freezing level, is much more lower from the ground. In that cases, snow can be formed. Any type of clouds that can produce also snow, but the problem is when this snow, as it is very feathery and light formation, when come back from a long distance, and typically from this type of region such as tropical and subtropical region, when this snow wanted to come back to the ground, then during this course they again get heated up, because from the environment they are heated up. So think about from a high, long distance from a cirrus clouds or high level cirrus clouds. So when these snow wanted to come back to the ground during this course of time, maybe 6 kilometers, 7 kilometers of this area, they are again heated up. And this heated up then turned back to them to a liquid formation or sometimes vapor condition. So that's why most of the cases in this tropical and subtropical region, snow, we cannot see the snow. Most of the cases, the freezing level in summer season in different areas, such as different parts of the USA and some parts of Europe, it is more than 3 kilometers in height. And then these also come back to a very lower level when it is in winter. That means in winter, sometimes it is less than 1 kilometer, sometimes it is less than 500 meter. So in that cases, these freezing condition helps them to come back to the ground as a snow. That means within this very lower distance, they don't actually get much heated up, and then we can see the snow. This is the condition of these snow formations. So that's why in most of the cases, snowflakes generally they come back from a distance of 300 meter. That means very lower distance. So when the snow form from a cloud and then the snow come back to the ground within this very limited distance, and this is one of the condition of the snow formations. But another interesting thing is snow and rain. They are in a positions that the cloud itself is a formation of the liquid and vapor droplets. So when it turns to ice formation, that means maybe snow, then they wanted to come, and maybe this is the area when they wanted to come, and melting level means after this level they are much heated up and they cannot retain their position. they cannot retain their state, that means in ice formation or solid formation, then again they turn to liquid state. So this is called melting level, or you can say the upper level is freezing level and lower level is the liquid level. So when they get heated up, again they come to ice to liquid, and this liquid when fall to the ground, we say this is rain. And these rainfall we can see and we can get, but we don't see the snow. But it might be also possible when these cloud formation is nearly the by the side of the sun rays. That means the sun rays can come in there, and that sun rays when come, we can distinguish between the snow and the rain from the same clouds, because we know the ice particles, they can scatter the light very easily. On the other hand, the liquid formation, that means the rainfall, they cannot actually scatter the light. Mostly they reflect the light. So what happened in most of the cases, the snow as it is a solid state, they scatter most of the light and they become darker. On the other hand, rainfall, they don't scatter much of the light, they actually reflect the light, and that's why they are more brighter, more lighter. So if you see this figure, you can see this darker position is snow. So if you have a view if it is very near to the horizon and the sunlights come in opposite direction, then we can see this part is little darker because this is ice, that means snow, and this is rain. And this snow is not coming to downward because when they wanted to come to the ground, then they heat it up and then they becomes rain or maybe another type of form. So this is one way to think. Another way to think that when the snow are coming from a very high level of the clouds, for example cirrus cloud, as I said, they are uh, much more time they have to come from a long distance, and these long distance they again turn to the vapor state. We say this is a sublimate state. So these they usually sublimate and then they again go back to the a state of vapor. Sometimes we also confused about, not confused, we can say they also behave like a varga. Varga is a state we discussed in the last classes also. Maybe you can remember, some of you can remember that. Varga is a state when the uh, ice state or liquid state come onto to down, they get heated up and they turn to vapor formation, and they are hanging up in the lower atmosphere, and they create a hazy state. They don't fall to the ground because they are vapor in condition, so they don't have enough gravitational attraction to pull them to the downward, so they remain in the atmosphere, and that is called varga. So those snowflakes which is coming from cirrus clouds, a high level of clouds, we call it fall streaks, and these fall streaks is working or behave like a varga. And why? Because this is also coming from a long distance and they get heated up and they again come to a state from ice to vapor, and they are also dangling white streamers to looking like. So that's why these fall streak, when descending to the lower positions further downward, the supercooled clouds can also be formed because they are very much in a lower temperature condition, but not ice, but not -0 degree, not lower temperature than the 0 degree. So that's why they cannot be a formation of the ice particles. So this is the way how can we describe the snow. Now there are different types of snows. That means there are many designs that can be formed, such as they can be plate-like structures, they can column-like structures, they might be needle-like structures, and most commonly they are looking like dendrite-like structures. Dendrite is a structures of looking like some branches of the trees or like flower. petals. Why that is more common than the others? Very interestingly, when the ice particles is coming from a moist air, um, that is slightly above freezing, slowly melting positions, when they come to the top, to the downward. So by the side of each of the layer that is moist in condition, and a thin film of water that is else taking place, because they are again getting the energy. And these thin film of water, they act like a glue, and they attract other snowflakes, and one after another, when they come together, for example, here is the main one, and then again this one come to here, so they form a ice formation design. And then again from here, when these snowflakes again melted up, so this one and this one, they come together and form, so they create a design like dendrite, like branches of the trees. So this thin film of water, that is the main reason that the dendrite formation is more common in most of the places. But the condition is that they should have a thin film of water by the side of that. That means they are a little bit heated up during course of time, and it is also possible because where they formed during course of time to come to the downward, they become again heated up, and this is very much common in most of the cases. That's why we see much of the dendrite design in most of the cases. Even dendrite, this type of design is more common when the lower temperature is 12 degrees centigrade to 16 degrees centigrade. That means when they wanted to come back with a heavy force, that means they are also taking some energy, and they become melted up. Snow. So when we say snow, that means they need a condition. They need some conditions to form, and these crystal forms is dependent basically two different types of condition. One is temperature, another is moisture condition. So if the moisture temperature is very lower, they become ice. And when they come to downward during course of time, if the temperature is much more heavier, then maybe again they come back to its original phase, like liquid or vapor. But again, if the moisture level is also very low, and if you have a warmer temperature, that time also it might be possible to form a snow. If the, such as an example is, if the air temperature is 8 degrees centigrade and the wet bulb temperature is 0 degrees centigrade, then the dew point should be 23 degrees centigrade. So it is also possible that with a greater temperature is relatively which is not very common, that if your temperature is more than 10 degrees centigrade, the snow is not very common, but it is still possible if your temperature changes relatively in a lower distance, and if you have very humidity condition is very different, then it might also be possible to form a snow. So this is all about the snow. Now, the snow, when they fall from the top of the ground, during course of this time, they can change different state. So snow is a solid state. When they come to downward, they become melted up, and again they become liquid formation. And again, when they come to further downward, if the downward structure is also cold and much more colder than the freezing level, then it become ice again. It become to form ice again. That means the liquid state from snow to liquid, and liquid to solid. And this solid state is very translucent and transparent, and it is not like looking like snow structure. It is not like to dendrite or any other formation. It is looking like a pile of the ice. That means very round shaped likely, and they bounce when they striking on the ground, or it can also producing some different sound when they fall on the window or piece of metal. It is like tapping sound, and then fall on this metal or window, they can get some sound. So slate is a position, that means they can become ice again, and this ice is not snow because they melted up and form again. See this one. So from a nimbostratus cloud, from here, the snow, the structure of the snowflakes, they come onto to downward, and during course of time they heat it up, and this is above freezing level. That's why they become come back again the raindrop stage, and further downward, when they go further downward, the time that these state again come back to a solid state, and this is not anymore this design, this is rounded shape now. So this is we called slate, and it is very much possible because if you see this red color, that means the distribution of the temperature, that also depends, very that also vary with the local temperature, with the local environment. Sometimes in the top of the state, you see this is minus temperature. When they come back, this is plus temperature. That means 0 degree. And again, in the lower temperature, it is become minus again. It also be possible in some of the structures, in some of the environment. And that time, this solid state we called as slate. Now, there are two different other types of rainfall. One is freezing rain, another is rime. Freezing rain, also called as glaze. So think about this stage. So here, if this raindrop is directly fall to the ground, okay, even it is lower in temperature, but if doesn't below the freezing level, in that type of cases, these raindrop fall to the ground with a very cold temperature. Okay, maybe nearly 0 degree centigrade. So that is we call freezing rain, or we can say glaze. Okay, so freezing rain or glaze is a rainfall or precipitation types that fall on the ground with a very lower temperature, and that have a less than 0.5 millimeter in diameter. That means the drop are very small, and these smaller drop, they are heated up during this stage, and when they finally fall, it don't have enough time to get heated, get less heated up, and then they don't have enough time or freezing state, they come back again in a solid state. So that's why freezing rainfall as a liquid formation. On the other hand, rime, which is a little bit different stage. So these raindrop, when fall on the ground, so forget about this one. So these raindrop, when fall on the ground with a very lower temperature, if the ground or the materials or the substances where these one form, maybe that particular materials is very much in a lower condition of temperature. That means they are minus in a minus temperature. It might be a metal formation, it might be some branches of the trees, it might be some buildings, or maybe some environment in some of the areas where we have minus temperature. That time it turned back to its solid state again. We called it rime. So rime means when the liquid formation form on the ground, and with a couple of second, it again turns to the ice because of the lower temperature of the materials. And then materials take the energy from there, heat from that particular freezing rain or what you can say, and then again they turn to slate. Sorry, again they turn to the ice. We called it rime. So if you see these two picture here, one is freezing rain or glaze, which is formed during 1998 near the Newark. If you see these freezing rain of the glaze that form on the trees or by the side of the wire, in between in the middle of the road, and they become so heavier that they cannot get the weight anymore, they cannot retain anymore, and a couple of branches are broken down. So this is glaze or freezing rain. On the other hand, these watery formation fall on the branches of the trees, and these branches or this environment is so cold. So after the falling of the rainfall, it turns to ice, and this ice formation is called rime. And you can also see the structure is much more different with the branches, because these branches give actually the support to form this rime, and branches are so cold that when the rainfall fall on it, the rainfall not become any more rainfall, they become a solid state and they form this rime formation. Do you have any question until this? Hello?
Sir, can you tell about sleet again, sir?
Slate again, okay. Slate is a formation. Slate is a formation of directly the water, the snowflakes, when try to come to the from the cloud to the downward. So you can see this structure. This is snowflakes. So during the course of time, if you see the red color in the right side, you can say this is the vertical temperature. And vertical temperature might be possible that sometimes it is going to higher and sometimes it is lower. You see this temperature. So if in here it is -4 degree, in here it is -4 degree, but in between this it is more than 0 degree. That means this is the condition where the snowflakes get heated up and they become melted up again. That means the solid state to liquid state. Okay. And again, when they fall further down, that means in here, again, they are in a positions of minus temperature. That means they again loses some heat to the environment, and they become this liquid, they become turned to ice formation and they form slate. Okay, someone asked me to explain dendrite again. Okay, dendrite is a formation of the snowflakes. Or it's looking like some branches of the trees, or we can say some fingerprints. Okay, uh, why it is looking like this? Well, as we know, the snow formation, it comes from here, no? So the freezing condition is in here. So in this layer, there are much more different state of the temperature. Okay, it is not similar everywhere because of the temperature distance from the ground, because of the environment. Somewhere it is more colder, somewhere it is less colder. So dendrite is a structure. Dendrite is a structure. Does okay. Dendrite is a structure. Hello, Siam. I don't know. Someone asked me from chat. এখানে তো দেখা যাচ্ছে যে তারা জিজ্ঞাসা করতে পারতেছে. So all of you can hear me? Hello?
Yes, sir. আমরা
Yes,
শুনতে
sir.
পাচ্ছি, sir.
হ্যাঁ, ওরা তো শুনছে,
Yes,
হ্যাঁ?
sir.
Okay, 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 okay. Okay, Siam called me because he has some disruption in the internet. Anyway, so these snowflakes, when they try to form during a moist condition, when they move further downward, they become melt again. So melted means, that means not fully melt, but a little bit of melting. So if you just think about the middle of this dendrite. So these dendrite, when they melted up by the side of this, melting up means a thin film of water, not mean to be that they turned fully to the downward. You can also have a good example when you get some ice from your fridge, just take one ice and keep your finger on that ice. You will see this is act like a glue. That means the ice, a little attraction with your hand. Why? Because a very slight water, thin film of water by the side of the ice, they attract your moist level of your skin. So they become very compact with your skin. But during course of time, when they get more heated up, then again they lose heat. Again they get heated up, and then they become watery and they fall from your skin. So similarly, in here also, in the middle of this one, when they have heated up slightly. So by the side of each one, there is a thin layer. So again, some structure, that means another ice formation, they come together, they form here, and they become glued, they become attracted by this one, and they become created some branches. And these branches again, they form another branches like this. And that's why in most of the cases in the moist air, this is not in one shape, they become one to another, and they finally form the snow. Sorry, I have to take another. Sir, जी sir. আমি ক্লাসে শেষে ফোন করব স্যার। জি, আসসালামু আলাইকুম স্যার। Sorry. So this dendrite formation is very much common in most of the moist cases, because if you see the plate or column like structure, it is when they move also in the downward from the moist air. So in the moist air, they become moist by the side of each of the layer. And then again, another ice when come together, they become attracted by one another and they form a lumpiness. That means they come together and join formation in a different shape. That's why dendrite is more common. Is it okay for you? Who asked me?
Sir,
Yes, sir.
স্যার
Yes, sir.
একটা কোশ্চেন ছিল স্যার,
Yes, please.
যা স্লাইডে লেখা আছে ডেনড্রাইটস আর কমন এট টেম্পারেচারস বিটুইন 12 degrees and 16 degrees.
Yes, that means when your down temperature is much more higher. Normally, what do you expect? Most of the cases we expect these snowflakes will be happen when your ground temperature is nearly 0 or 1, 2 or 4 or 5, yes, or maybe minus temperature. But it said dendrite also be possible when the temperature is 12 degree to 16 degree centigrade in the down state. That means when they wanted to come to the downward, they become heated up. And each of the cases are heated up. That means during course of time, the more branches will join together and they form dendrite. Is it okay?
আচ্ছা, আপনি এই পরের স্লাইডে যেখানে স্লিট তৈরি হয়েছিল ওখানে লেখা ছিল যে নিম্বাস স্ট্যাটাস থেকে পড়ার সময় স্নোফ্লেক্স টাইপস এর ছিল, তো
This one?
ওটা তো আগে থেকে এরকম থাকে না স্যার?
This one?
স্যার এর পরের স্লাইডে যেখানে স্লিট ফর্ম করছে, এই যে এখানে স্যার স্নোফ্লেক্সটা যে ডেনড্রাইটের মতোই দেখতে, এটা
Yeah, this one.
ইয়েস স্যার।
Yes, these are dendrite formed. Why? Because you see the temperature is increasing, isn't it? So when it is increasing temperature, they become come together. In even in the cloud, if the temperature differs, that time also it is possible to form snowflakes. Snowflakes, it doesn't mean this formation is happening in the down state. It can also be possible inside the cloud, because inside the cloud, that is not meant to be that always this is minus temperature. Even if it is minus temperature, if there is most moist condition, then it is also possible that other types of ice also come together. Okay, so that's why dendrite is more common than other types of structures. Okay, sorry, I have to take another call. Sorry to disruption. Sorry, I have another call from the institute. Sorry for the disruption. Anyway, so what I wanted to say that these structures, snowflakes, it can also be possible that their design also started from inside the cloud, because inside the cloud, if the moisture level is higher, then it is possible that they can also attract other sets of ice particles. That's why dendrite is more common. Is it okay now?
Yes, sir.
Okay, so another one asked me, does slate means what we call shilabisti? No, slate doesn't mean that. What we call shilabisti, shilabisti is, I'll describe now after this one, that is called hail. I'll come there. So we described about glaze, we described about rime. So we know how it has been formed, why it is different. Now we are coming for some hail, or what you are asking to me. So hail is a heart-shaped ice particles. It is not very soft. It is not like snowflakes. It is inside the cloud. When it is formed heart shape of the ice particles, it can be a lump of different irregular shapes. It can be round shape, it can be different shape. You can see this one also. There are many tiny particles. They join together and form a bigger one. So this is particularly coming from a cumulonimbus type of clouds. And these cumulonimbus type of clouds, what happened, most of the cases at first, they produced a smaller ice formation. And this smaller ice formation is coming from a name from Graupel. Graupel is a large formation of the raindrops. That means a bigger raindrops, they turn to ice, first of all. And that is act as an embryos. That means center. When the center accumulates more liquid together, each of the liquid turn to the ice formation. That means supercooled liquid droplets come together to an embryo, and that embryo again when they moves, that created a ice particles that form a hail. Now the interesting thing is a million of cloud droplets is needed for a raindrop. That means a single raindrop. But if we wanted a golf ball size hailstone, they need at least like this one or more than that one, a little bit bigger one. 10 billion of cloud droplets is needed to form that one. How big it is. So altogether they form a hail, a single one, a single hailstone. Now the thing is, if you see this figure, very interestingly, why you can also ask me the question, why when it is coming to downward, why it is not melting up again? Yes, they can also melting up, but the very interestingly, hailstone, when hail formation happened, when they come back, surely they will change their nature, their state from heart shape to liquid state. That is very common. But the one condition is in there. You need a updrafts. What do you mean by updrafts? Updraft means the wind which is moving from down to upward. If this is happened, then what happened? This embryo, that means the hailstone embryo, they remain in the air for a couple of minutes. Sorry, they remain in the cloud for a couple of minutes. You see, this is a 0-degree temperature. That means this is upper here, this is freezing level. Downward, this is not freezing level. But to form a bigger hail, that means a bigger chunk of the ice formation, it is not possible without the updrafts. Because when the hail formed with the heavier portion, because it is too weighty, it wanted to come back to the downward, but it cannot come back because of the updrafts. That means the wind from down to upward. So they remain, even they are very bigger, but they remain in the air for a couple of minutes. At least if you wanted to make a bigger hail, at least 5 to 10 minutes, they should remain in this level. That means more than the 0-degree, lower than the 0-degree level. That means in the freezing condition. And then again form and come a bigger size, okay? And they come in these stages. And with the horizontal air movement, when this is moved forward, this level is no more in there. That means they cannot remain in the top of the atmosphere, in the top of the clouds. So the upper level of the clouds, ice, move forward, and this type of hails when they are starting in a positions, they just fall to the downward with the raindrops. And you can also see that hail always come to your downward within a couple of minutes. It not last long for 1 or 2 hours. Because of that, because this ice formation, they move forward and the updrafts is no more in there. So that's why when the hail come to us, within a couple of minutes, a huge amount of the ice chunk fall on the ground. This is your experience also. If you see the hail formation, hail is coming with the rainfall. This is only for a couple of minutes. It is not last long for hours and hours. Because of that, because the updrafts is not possible with a long time, and because also these horizontal movement of the air also possible to the further forward. So because of these two, the hail formation is happening within a couple of minutes to the downward. They become with the come to the ground with the rainfall. So this is hail. Can you understand now? Who asked me the question about
Sir,
hail?
what makes them fall together in the ground, sir?
Sorry.
Sir,
So-
what makes them fall together, sir?
Because of them, because of their weight, because the updraft is no more in there. You move your the clouds is moving horizontally further, so this updraft is not working anymore, so hail become more heavier, and then your gravitational attraction force, they take to downward because it is ice, it has weight.
Yes, sir.
Okay, they can understand it. Okay, now another two types of precipitation, I'm not going to describe it, just mist and graupel is two types of liquid substances. Mist is the smallest formation like drizzle droplets which can be visible, and graupel is the bigger size of the rainfall which is at watery, that means a bigger, very big water droplets, that is we call graupel. Now we are going to describe very briefly about the precipitation measurement, and this is very important because how we can measure the precipitation, how we can say today this amount precipitation has been seen in a particular area. How can we say that? So we have to measure it. So three different ways we can measure it. One is direct measurement with the instrument, and another two is two different technology we can use for precipitation measurement. Direct measurement also included two different types. One is standard rain gauge, another is tipping bucket, and another two is the technology we can use, radar and remote sensing. So I'm now going to describe it very briefly. Precipitation can be measured, as I said, 1 millimeter precipitation means 1 kg of water. If you just put in a 1 meter square area, the height resembles 1 millimeter. So now you think about that. If you can drop a bucket in an open space, and after a certain period of time, for example, 1 hour, 2 hours, or 6 hours, or 24 hours, you can get the precipitation and you can measure it. So this is very simple. But this is not very accurate because during 24 hours, the water can be fill up the area, the bucket, and you need to change it. On the other hand, maybe evaporation takes place and some of the rain water can go away. So your measurement may not be very complete, may not be very accurate. So we can use some standard rain gauge, which you need your attention most of the time. So it is a two different cylinders. One is bigger, another is smaller. A smaller one is measuring cylinder, which is 1/10 of the main one. And the mouth of this one, we can keep a funnel so that this funnel can give all the rainfall fall on this top. That means the 1 inch circumference of this one, and that fall on this one, which is 1/10 of the measuring cylinder. So if you have this amount of the rainfall, that means it is 10 times 1/10 of the main one. Okay, so this can easily be multiplied and we can get our measuring amount of the rainfall. And now another one is tipping bucket rainfall, rain gauge, which is nothing more. We can add a recorder in here. So this is a layer where the rainfall fall, and this is a tipping bucket. Tipping bucket means it can go left or right with the amount of the rain, with the amount of the weight. So if the weight is in the right side, they can go right side. If the then after a certain condition, when they come in this way, the water fall on there, and again they go up, and again the rainfall come, and again they go downward. So with left and right, when they move, there is a wire inside here, so that this weight can pull a trigger in here. This trigger is associated with a marker or a pencil with a graph paper. So when they pull direct or downward, the graph also go downward or upward. And again, they when go upward, that graph also go up and down with this pencil. So this is some semi-automated version where you need not a very constant attention. And after a certain hours, maybe after 24 hours, you go there and get the graph and you can analyze it. So it is also possible. It is called tipping bucket gauge. Then the radar. We can use the microwave to send from the ground, and these microwave, when get inside the cloud, they again come back to the some of the portion of them, they come back to the radar sensor again, and that we called return echo. That means we send the microwave and then objected or obstacled by the cloud, and then again they come back and we receive it. So depending on the time, depending on the types, we can also analyze these microwaves, and we can estimate what is the length of it, what is the width of it, and what is the types of it. So altogether, when this information we put in a model, we can get a certain amount of the rainfall that can possess by this cloud. So before the rainfall, we can also analyze from a particular type of cloud that how much rainfall can be possible from that type of cloud. Similarly, precipitation also can be measured through satellite image, because from the satellite image, we can get the reflected ray from the satellite, and then we can analyze it. Different sets of water depth, they can give you different sets of rays, reflection. And from the satellite, if you can get it, if you see this figure, this is a satellite image of Hurricane Humberto in 2007. So precipitation rate can be easily be seen by the satellite image here, or maybe also radar image also you can use. So satellite image can give you the understanding that different sets of depthness, width, and the area of the clouds, so that you can understand how much water can be possible from a particular type of clouds. Similarly, when it has been happened, if you have the measurement, or you wanted to see which type of liquid is in there, or what, and during course of the time, if you have similar different sets of images all together, you can also say in here how much precipitation has been happened. So this is a structure how we can get this energy. So this figure has been made up with the data from the precipitated data, and then they form different color variations so that they can understand where the precipitation happened mostly. But you can also get these images from the clouds, because from the clouds you can see where the precipitation can happen. So before the precipitation, you can analyze the clouds and you can get your information. So 3 different ways you can analyze the precipitation. You can get the measurements. And that is all for this chapter. Now, if you have any question, you can ask me. Any question regarding today's class? Can you understand me? Can you hear me?
Yes, sir.
Okay. So if you do not have any question, I think you can understand it. In your exam, it might become like describe briefly about the technique of precipitation measurement through radar, or how can you measure precipitation through remote sensing, or how can or briefly describe the tipping bucket rain gauge. Okay, so it would be better if you can show in a figure it. Okay, just to make us understand, not very fine drawings, but make me understand. Or maybe it can also come how a hail can be formed, or how a snow can be formed, or how what do you mean by slate, what is the characteristics of slate or snow. Okay, is it okay for you? Can you answer it in your exam?
Yes, sir.
Okay, so if you do not have any question, then may I ask you, give me another time in Wednesday. Are you free in the same time in the Wednesday?
Yes, sir.
Okay, so I'll send you the link, and hopefully we'll meet you in Wednesday. Okay, thank you all.
Assalamu alaikum, sir.
Wa alaikum assalam.
Assalamu alaikum, sir.
Assalamu alaikum, sir.
Wa alaikum assalam.